Welcome to the e-learning platform, an initiative by Science Park, Savitribai Phule, Pune University. Let's start with part 2 of our chapter Acids, Bases and Salts for Standard 8. Subtopics for this video are Introduction, then we'll get to know some household bases that we use in daily chores. We'll see scientific definition of a base. We'll see some common bases and their chemical formulas. Then we'll see some important properties of bases. We'll get to know about neutralization reactions. We'll get to know about pH scale, and with that we will see some examples of soil. Now, just to summarize this, we'll cover all these properties, all these points while thinking about bases. We'll see what are weak bases and strong bases. We'll see their properties, we'll see the scientific definitions, some reactions, and then we'll see some common bases that we use. Now, household bases that we use in daily chores are baking soda, sodium bicarbonate, खाण्याचा soda. Then all the kind of soaps that we use. Ammonia we use for cleaning. Drain cleaners, shampoo, glass cleaners. All these are bases. So what are the common household substances that we use are acidic and basic. So I have listed some of them. You can go on increasing the list here. Let's see some scientific definition of a base. Substance which reacts with an acid to form salt and water are called as a base. Now let's see this reaction. When an acid is added in a base, a salt is formed and water as a byproduct. This kind of reaction is also called as a neutralization reaction. Now bases reacts with acids to produce salt and water. We have seen that. Now ammonium salts are used to react with base to produce ammonia, which is a very important product. So sodium hydroxide, caustic soda, it's a very strong base. It reacts with ammonium chloride and forms sodium chloride, that is table salt, and pure ammonia plus water as a byproduct. Now I have listed some common bases. I have written their chemical formulas and their names here. Now you have to pause the video here and match the formula with its particular name. And then you can recheck your answer with me. So what is an alkali? So alkali are bases that are soluble in water. So bases can be branched into two different ways, soluble in water and bases which are insoluble in water. Bases which are soluble in water are called as alkali. Now let's see some important properties of bases. Bases forms hydroxide ions, OH minus ions, when dissolved in water. Bases turn red litmus paper into blue. Bases has a pH range of more than 7. It is bitter in taste. You feel slippery if you are handling a base. When acids and bases react, the product is always a salt and water. Let's see what is dissociation of base. Alkali when dissolved in water. So let's see this. Let's see the dissociation with an example of sodium hydroxide. Now I have deliberately kept the background blue just to understand that it's a background of water. Now in this water, when I put sodium hydroxide pellet, all the Na sodium ions get separated as Na plus and OH gets separated as OH minus ions. And then now my water is spread with equal amount of Na plus ions and OH minus ions. So how can I write this reaction? NaOH gives me OH minus ions and H plus ions in water. Now let's see the difference between acids and bases. You can pause the video here and write down the difference of acids and bases in your notebook. Now here acids form hydronium ions when dissolved in water. Bases forms hydroxide ions when dissolved in water. Acid turns blue litmus paper into red while bases turns red litmus into blue. Acids always have pH lower than 7. Bases will have pH higher than 7. Acids react with metals and will have a sour taste. But bases always will have a bitter taste, and if you take base in your hand, it feels slippery to your hands. Now this last point is same for both acids and bases, that when acids and bases react, the products are salt and water. Let's see neutralization reaction. In neutralization reaction, H plus ions from acid and OH minus ions from alkali react to form water. Now always and always this kind of reaction is exothermic. It gives away energy. Let's see some examples of oxides. There are 4 types of oxides: basic oxides, acidic oxides, neutral oxides, and amphoteric oxides. Amphoteric oxides are those which sometimes behaves like basic oxide and sometimes will behave as acidic oxide. Let's see some examples of basic oxides. Sodium oxide, calcium oxide, ferric oxide, all are basic oxides. So if I prepare a solution of ferric oxide and put litmus paper into that, it will show me pH higher than 7. So it will turn my red litmus into blue. Amphoteric oxide, some of the examples of alumina, zinc oxide and water. Now here water is very special. If the basic ion concentration is more in water, it will show me pH higher than 7. If some acidic ions are there in water, it will show me acidic. The water will have pH lower than 7. Acidic oxides are carbon dioxide, sulfur dioxide, phosphorus oxide. All these are acidic oxides. Now carbon monoxide and nitrogen monoxide are neutral oxides. Now what is this pH is all about? This is a logarithmic line that we have done for our own understanding. Now on this line, this 0 means super acidic. Now as you go from your left to right, acidity goes on decreasing till 7. 7 is always neutral. As you pass 7, basicity goes on increasing. So after 8, 9 is here. So sometimes some substances or solutions also show us a shade of pH paper between this blue and this very faint blue. The pH is then 9. So on and so forth. So I have listed here some of the pHs of common substances that we use in our daily chores. So when you are experimenting on substances around you, you can recheck your answer with this table. Now let's see where do we use this pH. Now in most of the industries or in research laboratories, the first thing that we check is we check the pH. So I have taken the example application of pH in soil because it is very important. Every farmer needs to know what is the pH of its soil for it to be very fertile. So theoretically, plants grow naturally well in neutral soil. So plants grow poorly in very high or very low pH. Now most of the time we always come across the acidic soil. Now why soil becomes too acidic? Because of excessive use of chemical fertilizers and because of acid rain. From air, all the pollution by sulfur dioxide and nitrogen oxides, they all go in soil and eventually soil becomes acidic. Thank you.